today we are going to start second chapter from algebra, that is quadratic equations. So let us see what quadratic equations are. The equations involving one variable and having maximum index of the variable as 2 is called a quadratic equation. So here is the standard form of a quadratic equation. Standard form of the quadratic equation is ax square plus bx plus c is equal to 0, where a, b and c are real number and a should not be equal to 0. But if b is equal to 0, then the equation becomes ax square plus c is equal to 0. And if c is equal to 0, then the equation becomes ax square plus bx is equal to 0, where a, b and c are also called as quadratic coefficients. Now let us see what are the roots of a quadratic equation. Values of the variable means either x, y or z, which satisfy the given equation are called as roots of the quadratic equation. So after introduction of quadratic equation, let us start with exercise or problem set 2.1 from your textbook page number 34. So the first example is write any two quadratic equations. You have to write any two quadratic equation. I have purposely written here OEQ. It is an open-ended question. That means anybody can write any equation, but it should be a quadratic one. So here I have written one quadratic equation as x square plus 4x plus 3 is equal to 0, and another one 5y square plus 3y is equal to 0. You can choose any other quadratic equation of your choice because it is an open-ended question. Now the second question is decide. You have to decide which of the following equations are quadratic equations. So the first equation which is given to you is x square plus 5x minus 2 is equal to 0. So in this equation, in this particular equation which is given to you, x is the only variable. No other variable is there. X is the only variable with highest index as 2. Therefore, as the index is 2, given equation is a quadratic equation. Now let us turn towards example number 2. What is that example number 2? Y square is equal to 5y minus 10. As the equation is not in a standard form, let us convert it into standard one. So shifting of 5y here, it becomes y square minus 5y. This minus 10 will become plus 10 is equal to 0. Once again, here the only variable is y, whose index is 2. Therefore, given equation is a quadratic equation. Now the third example is little bit different one. Y square plus 1 upon y is equal to 2. So as y is in the denominator, let us multiply by y throughout the equation. So here I have multiplied y into y square plus y into 1 upon y is equal to y into 2. So y into y square will give us y cube plus y into 1 upon y. Here y will get cancelled. So you have only 1 is equal to y into 2 is equal to 2y. So y square plus 1 is equal to 2y. Shift 2y here. It will be y cube plus 1 minus 2y is equal to 0. Write it in a proper way. Y cube minus 2y plus 1 is equal to 0. So here I have purposely written your conclusion now. Why? Because now just see the variable y whose highest index is 3. For a quadratic equation, the condition is highest variable's index should be 2. Here the index is 3. So therefore given equation is not a quadratic equation. Let us move towards example number 3. So in example number 3, you have to write the following quadratic equations in ax square plus bx plus c is equal to 0 as a standard form. And after writing in a standard form, you have to write the values of a, b and c. Look at the first equation here. 2y is equal to 10 minus y square. So we'll shift all the terms to left hand side. 2y minus 10 minus y square will become plus y square. So it will be 2y minus 10 plus y square is equal to 0. Write it in a descending order of index. So it will be y square first, then 2y, then minus 10. So it will be y square plus 2y minus 10 is equal to 0. Comparing this particular equation with our standard form, ax square plus bx plus c is equal to 0. Here the variable is y, but in our standard form the variable is taken as x. Okay. So after comparing, what we have, a is equal to 1, b is equal to 2 and c is equal to here I have written b, but it should be c. C is equal to minus 10. Now we'll turn towards example number 2. What is that example number 2? X minus 1 whole square is equal to 2x plus 3. Let us open the bracket x minus 1 whole square by using formula a minus b whole square. So what is the expansion of x minus 1 whole square? It will be x square minus 2x plus 1 is equal to, here you have 2x plus 3. So I have written it as it is. Now shifting 2x and 3 to this side, what we have, x square minus 2x plus 1 minus 2x minus 3 is equal to 0. Collecting like terms, you have x square minus 2x and minus 2x will give us minus 4x plus 1 minus 3. One is plus, another one is minus. It will give you minus 2 is equal to 0. Once again, we have to compare it with ax square plus bx plus c is equal to 0. So after comparison, what we have, a is equal to 1, b is equal to minus 4 and c is equal to minus 2. There are few more examples from example number 3. You can solve them by using similar method. Now we'll turn towards next example, that is example number 4. So here we have to decide, or we have to determine whether the values which are given against the quadratic equation are the roots of the given quadratic equation or not. So the first equation from this is x square plus 4x minus 5 is equal to 0 is our quadratic equation which is given to you, and the values are x is equal to 1 and x is equal to minus 1. We have to decide from them which is the root of the given quadratic equation. So here let us substitute first of all x is equal to 1. So what is the LHS? X square plus 4x minus 5. LHS means left hand side. So I have taken left hand side. I'll be substituting x as 1 first. So it will be 1 square plus 4 into value of x as 1 minus 5. 1 square is equal to 1. 4 into 1 will give us plus 4 minus 5. 1 plus 5, 5 minus 5. 5 minus 5 will give us 0, and 0 is the value of RHS. So LHS is equal to RHS. Therefore, x is equal to 1 is the root of the given quadratic equation. Now what is the another value? X is equal to minus 1. Let us substitute x is equal to minus 1 here. So what is the LHS once again? X square plus 4x minus 5. I'll be substituting value of x as minus 1. So it will be minus 1 square plus 4 into minus 1 minus 5. Minus 1 square. Square of any number is plus. So minus 1 square will give us 1 plus 4 into minus 1 is equal to minus 4 minus 5. 1 minus 4 minus 5 will give us minus 9. 1 minus 9 is equal to minus 8. But minus 8 is not equal to 0. That means LHS is not equal to RHS. Therefore, x is equal to minus 1 is not the root of given quadratic equation that we have determined. There are some more examples you can try by using similar method.